Hey guys, welcome back to the channel. In today's video, we will learn how to implement username and password based authentication in a Spring Boot based REST API. And we will implement this using HTTP Basic Authentication. When we talk about HTTP Basic Authentication, it is probably one of the simplest and commonly used authentication mechanisms which are available. So in this video, we will follow a step-by-step plan. We will start with a Spring Boot REST API. Then we will implement Spring Security, and then we will implement HTTP Basic Authentication. And by the end of this video, you will know how to secure your APIs using HTTP Basic Authentication. And before we start, please check out the first video which was on the Spring Security architecture so that you understand each and everything that we are going to discuss today. Let's get started. Let's start with HTTP authentication mechanism. What is this? HTTP authentication is a very simple authentication mechanism. It is a way for a user or a client to provide their credentials. And generally, these are in the form of username and password. So here we have the client and the server. Client wants to use some functionalities provided by the server. So client needs to authenticate itself. For that, client will provide the username and password. Now this username and password will not be sent to the server in a plain text manner. It is first encoded using base64 encoding. And this encoded value is sent using the authorization header. So as you can see, this is the authorization header which will be set by the client in the request. The value of that header always starts with the text basic. And this encoded value that you see represents the base64 encoded value of username and password. Now this represents the credential of that user. When the request reaches to the server will check the credential. It will decode the value, basically this value, and it will check if the user exists in the database. It basically performs the authentication. If it is able to perform the authentication successfully, if it identifies the user, then it sends 200 an OK response back to the client. Otherwise, it is marked as unauthorized and the authentication fails. So that's what HTTP Basic is all about. You encode the username and password using base64, then you pass this value in the authorization header, which always starts with basic and the encoded value. The server will decode the value, it will find the user, it will check the password. If everything matches perfectly, then the user will be authenticated and a successful response will be sent back to the client, and then the client will be able to access anything that is protected. Otherwise, a 401 unauthorized response will be sent to the user that, hey, the authentication failed. Okay, so before we move on, let me quickly show you how the username and passwords are encoded using base64 encoding. So you can find many encoders and decoders online. Here is one that I'm going to use for the demo. Let me clear the screen first. So for example, let's say the username of the user is user and the password is pswd. Now this combination will be joined by the colon, and this whole value will be encoded using base64 encoding. So after the encoding process, your username and password will look something like this. This is an encoded value. What server will do when it receives the value in the request, it will decode the value. So if we try to decode the same thing using base64 decoding, you can see it will be able to see the username and password which were sent in the request. And now the server can use this username and password to basically apply the authentication mechanism. That is what base64 encoding and decoding is all about. Now, as you can notice, this is simply an encoding. This is not encryption. So this value can be decoded back, which means it's not secured. So if anyone gets your encoded value, he or she will be able to decode it back, and he or she will know the username and password that were provided. So to make it more secure, it is generally used with HTTPS. Having said that, HTTP Basic Authentication is a very simple mechanism. That's why it is more suitable for, let's say, internal applications or very small applications. By internal applications, I mean, let's say there is an organization which is running all the applications behind a boundary. So that means it is only accessible by, for example, a set of employees which are already authenticated. So in such scenarios, we can use HTTP Basic Authentication. Otherwise, this encoding is not strong. It can be decoded. Now that we understand base64 authentication and encoding and decoding, let's see how can we implement this in a project. Suppose we have an API that we want to protect using Spring Security. Then we have the user. This user wants to use the API. In order to use the API, the user must authenticate himself. And as we are using HTTP basic authentication, so what we are saying, user must provide the username and password. When the request reaches to the API will decode the value as we saw using base64 encoding and decoding. So the API know the username is this and the password, for example, is PSWD. Now the first thing that we need to do is we need to identify, or we need to find out if the user exists in the system. So that means we must have a user store. Now this user store will store the information related to the user, like username, user email, or password. Otherwise, how do we identify, how do we match the user? We need a user store. Now this user store can be a database, a relational database, or a NoSQL database, or there could be an API which is responsible for managing the users. Now our API in this case will call this API to find the user information. This is also one way of implementing the user store. Or we could use a third-party solution to host or to store the users. So there are a couple of options to implement a user store. The important thing is we need to store the users. We need to have a user directory or repository. So what API will do, it will try to find the user using this user store by this username. Let's say if the user does not exist in the user store, then API will return an error that it is a non-existent user. I cannot find the user. But if the user exists, it will get a user back. And in that case, what API will have to do, it will match, let's say this user is you, then it will match this password with the password which is returned by the user store. If it is matching, then it means it is a genuine user, authentication is successful, the API will return 200 response. For example, the user is authenticated and now user can access the secured endpoints of this API. But if it doesn't match, then it means user has provided wrong credentials, and in that case we can send, let's say, 401 that hey, you are unauthorized to access this API. So there are two important things that we need to do. First, we need to have this user store where we will store the users, and then we need this password matching mechanism. Now with this thing in mind, let's move on and understand the project that we are going to develop. So here we have this project outline, how our API would look like and how the project will work with Spring Security to secure the endpoints. Let's focus on the top part first. So here, as I said, we need a user store, and for the simplicity, we'll start with the simple solution. That means we will have a MySQL database, and in this MySQL database, we will store the user information. That means username, password, and email. So we will have a MySQL database. Now, in order to store the data and read the data from MySQL database, we will simply use Spring Data JPA. So we will have a user repository. Then we will implement a user service that will work with this user repository, and this user repository will interact with the database. Then we have a controller, and as this is a no security check, that means it will be a public endpoint. That means anyone can access this endpoint without authentication. Why we need a public endpoint? Because we need to register the user first. So there will be this endpoint API/register. For example, the user will first use this endpoint. It doesn't need any authentication because this is a public endpoint. And using this controller, this service, and this repository, we will store the data in the MySQL database for that user. And once we have the user in the database, let's say when the user is trying to access a private endpoint, which is this controller, the second controller, which represents a private endpoint, which is secured by Spring Security, then that means whenever the user is trying to, let's say, access this endpoint API/create, then the user must be authenticated, and that's when the Spring Security part will be triggered. And we also know the user will provide the username and password, which will use HTTP Basic. So the value will be sent in the authorization header, which starts with basic and the base64 encoded value. All right. So when the user provides the credentials, we know the Spring Security part will trigger, which will start with step 2.1 before it can access the controller. Okay. And this is the part coming from Spring Security architecture, which we have already covered in the last video. So make sure that you watch that video first. Otherwise, you will not be able to relate anything. So we know there will be a Spring filter in the filter chain, which will trigger the Spring Security filter chain, which will pass the request to Authentication Manager, and the Authentication Manager will select an authentication provider. And in this case, this authentication provider is related to HTTP Basic. All right. And this HTTP Basic authentication provider knows how to authenticate a user or a request using HTTP Basic mechanism. That is the role of authentication provider. Each authentication provider is responsible for a specific type of authentication. So in this case, this will be HTTP Basic Authentication Provider. Alright, now when the authentication provider starts the execution, it needs to know the user. As we discussed in the previous slide, we need to find the user first. So how do we find the user first? From the MySQL database. We know we have the repository, but we have to provide some way to read this user data from the MySQL database to Spring Security. That will be used by authentication provider. And we discussed in the last video, we can use UserDetailsService, which is provided in the Spring Security framework or in the dependency. And using this UserDetailsService, Spring Security will know how to load the user. So this UserDetailsService will work with the existing user service, and this user service will then talk to user repository, which is an established flow already. It will read the user from the MySQL database. So there we have the user data. All right. And then this authentication provider will use this user data, which is returned from the MySQL database, to match the username, okay, and the password. And if the authentication is successful, then it will store an authentication object in the security context holder. And for the demo, we will access this authentication object in this controller to, let's say, print a message. That is the overall flow that we are going to implement in this demo. And one thing I missed, the role of PasswordEncoder. So in the registration flow, which is this one, when we store the user information in the MySQL database, instead of storing the password in a plain text manner, we will use this PasswordEncoder bean to basically store the password in the hashed mode, in the hashed format, so that the passwords are more secured in the database. So what are the key components that we are going to develop? We will have two controllers. We will write these two controllers, then a user service, a user repository, okay? And then we will also provide an implementation of UserDetailsService and a bean of PasswordEncoder. Then we will also configure the Spring Security Filter Chain in the project. We don't need to actually configure all this. This will be handled by the Spring Security. So I hope you understand the overall flow that we are going to develop. Now let's move on and start with the hands-on. So here we have the sample project. To save some time, I have developed a skeleton project which already has the Spring Data JPA part, okay? Not the Spring Security, but the simple Spring Data JPA part to register the user. This thing we already know about. If you're not comfortable, please check out this playlist. Okay. So starting with the application.yaml file, in this YAML file, I have provided the database configuration of my MySQL database. So I have a database Spring Security demo, nothing special about it. Going to the user controller, this is a very simple user controller which is exposing a post endpoint, okay, to basically register the user. So we receive the request, then we map the incoming data to user DTO, which is a very simple DTO with 3 fields, username in, password, and email. All right. Then this controller will pass on the request to user service. Let's go to the user service. This is a very simple user service. It is using the user repository. And here we are using Spring Data repository, so nothing special about it either. Going back to the service, here we are actually creating the user entity. So this is the user entity that we have created. Okay, simple Spring Data JPA entity with 3 fields and 1 primary key. All right. Going back to the service, we map from the DTO to user entity, and then we are calling save method of user repository to save the users. So let's start this program and try to see if it is working. So the service is up. Let's try to add a new user. For that, I'm going to use Postman. Now this is the URL of my controller, register controller /API/user/register. And we are going to use a post request because we want to create or register the user. There are 3 fields: username, demo, password, demo123, and email, demo@gmail.com. So let's hit the request. And we got the response, user created successfully. Let's check the data in the database. This is the database that I created, Spring Security demo. And in this, we should have the user table. And if we check the user table, we should have a single row, the user that we just created. So ID is 1, email, password, and demo. So that means the basic flow is working fine. So far, we are not using anything related to Spring Security. Now that we have a very basic simple API, let's secure it using Spring Security. So the first thing is, if you notice, we are storing the password in the plain text manner. So it is clearly showing the password of this user that the password is 123. How do we secure it? As we covered in the architecture diagram of this project, we need to use the password encoder. And how do we get the password encoder? Well, we need to use the Spring Security. So let's start by adding the Spring Security dependency to a project. We'll go to the project. Let me stop the application and we'll go to the pom.xml. Here in this pom.xml, we simply need to add a single dependency that is for Spring Security. This is the one, Spring Boot Starter Security, and this is coming from boot. That's it. And let me reload the project. Okay, so it has downloaded the dependency. Now, without changing anything, just by adding the Spring Security dependency, if we restart the application, let's see what happens. So as we can see, Spring Security is now securing the application. How do we know? We can see this log message in the logs that using generated security password. So what Spring Security is doing, by default, it secures all the endpoints. And at this point, it doesn't know anything about the user store that we are storing the user in a MySQL database. So what it does, it creates a dummy user and it also creates a dummy password for us to use. And every time when we start the application, it will create a new dummy password and dummy user, of course. So this time, if we, let's say, hit the same request, we get the 401 unauthorized because now this endpoint is secured by Spring Security. So just by adding the right dependency of Spring Security, the application is secured. But of course, we don't want to use the dummy user and password. We want to use the users that we are creating in the MySQL data store. So let's do that. Let me stop the application. And the first thing that we will do, we will create a config file where we will provide security related configurations. So in the config folder, we will create a security config class. And this is going to be a configuration class. So we will use @configuration annotation. All right. And in this annotation, in this config file, we will create a new bean. And this is going to be a password encoder, which is coming from Spring Security. Okay. Now, there are many password encoders available in the Spring Security. You can Google it. You will find the documentation. The one we are going to use is bcrypt. Like this. It is as simple as that. And now that we have this bean available in the context, we can use this password encoder same as any other bean in a Spring project. So we'll go back to the user service where we are storing the user information. And the first thing we will do, we will auto wire this password encoder. Like this. And then we can use this password encoder to encode the password. Okay. So where we are storing the password or where we are assigning the password to, let's say, this user entity, instead of assigning the simple password in the plain text manner, what we will do, we will now encode this password. Like this. So whatever the user is providing using the registration endpoint, what we will do, we will encode this password. So now what will happen in the database, we will see the hashed password, which is more secured. So let's start the application and test this flow. So the server is up. That means we are at least configuring the password encoder right. But how do we test it? We don't want to use the random password or the default user. We want to use the user that we are creating. All right. So how do we do that? Step number 1 was to integrate the Spring Security by adding a dependency in the pom.xml. Then in step number 2, we created a new bean of password encoder that we will use to encode or hash the password while storing the user information. And the same encoder will be used to match the password in the authentication flow. Now, the step number 3, which is probably the most important step, is to configure a Spring security filter chain. All right. And how do we configure the Spring security filter chain? We'll go back to the configuration, which is security config. And same as password encoder, what we generally do, we provide a new bean of security filter chain. So let's do that. We need to create a new bean of type security filter chain. This security filter chain will use something called HTTP security, which will be initialized and injected by Spring Boot. So we don't need to worry about that. Once we have the access to this HTTP security object, what we generally do, because it follows the builder model, so we do something like this, and here we can configure the Spring security filter chain. So the first step is, first of all, because now we are configuring and overriding the security filter chain, we need to tell Spring Security that what kind of authentication mechanism we are going to use in this application. Since we are going to use HTTP Basic, so we can provide that information using HTTP Basic builder method. Then, as you can see, it accepts some parameters, and these parameters are basically an object of customizer dot with defaults. What it will do, it will tell Spring Security that we want to use HTTP Basic Authentication. Then it will apply the default configurations of HTTP Basic. Of course, if we want to override some configurations, we can do that, but default configurations would do just fine for the demo. So one, we have configured the HTTP Basic Authentication mechanism. Second, because this is going to be a registration endpoint, for this demo, we will keep this endpoint as public, as we covered in the architecture diagram, so that anyone can use the register endpoint in order to register first, and then the user will be authenticated. So how do we exclude the endpoints from the authentication process? Well, there is another method here, authorized HTTP requests, like this. And again, it accepts a lambda. So we can do something like this. Okay. And auth request dot any request dot authenticated. So by writing this code, we are telling Spring Security that all the requests, any request, that means all the requests will be authenticated. And that is the default behavior of Spring Security. By default, it secures all the endpoints. But what we want to do, if we go back to the user controller, we want to make this endpoint public so that any user who doesn't have the account yet can access the endpoint in order to register itself. Okay, so we want to make this endpoint public. How do we do that? We'll go back to the user config, the security config, and the order matters here. The first thing we will do, we will use a request matcher like this. And in this request matcher, we will provide the endpoint. We can also provide some wildcards, but in this case, because we have a single endpoint, so what I can do, I can simply go back to the user controller. I can simply provide this endpoint /API/user/register and permit all. So what is happening here? We are telling Spring Security that all the endpoints that we provide here, you need to match the incoming request and you need to permit them. Do not authenticate. But anything else, any other request which is not part of this expression will be authenticated. So using this, we can exclude endpoints from being authenticated. So far what we have done, we configured the Spring Security filter chain. Then we are making this endpoint public. Anything else will be authenticated. We also configured password encoder, and we are using this password encoder in the user service to basically encode the password. So now we should be able to access this endpoint without being authenticated. So let's try that. And since in the application.yaml file, we have ddl-auto configuration as create, that means the data must have been deleted. Okay, so the user table is empty. That's good. So the service is up. Let's see if we can make it work. We'll go back to the Postman and we have the same request and the same body. The only difference is now we are configuring the security filter chain and we are making this endpoint public. But if we try to send a request, we are getting 401 again. That means there is something wrong, but we don't see anything in the logs. That is another important point. Let's say in case you are not able to see anything in the logs, why something failed, then there are some logging configurations specific to Spring Security that we can enable. So I have this ready. I can simply paste the logging configuration. So let's enable them like this. And let's restart the application. The service is up. So let's retry. And this time we can see a lot more details in the logs and we see an error, invalid CSRF token found. So by default CSRF is enabled, which is failing this request. So we'll go back to the security config. We will disable the CSRF for this demo. Generally, we don't disable the CSRF because this is critical for security purposes. But because this is a purely backend application, this is a REST API, there is no UI or frontend involved. So in that case, we can disable the CSRF. How do we disable the CSRF? Well, we follow the same builder method model. So there is another method here, CSRF, which accepts a lambda. Okay. And using this lambda, we can disable the CSRF. Having done this, let's restart the application and see if it works this time. So the service is up. Let's retry and see if it works this time. And this time we see 200. Okay, user created successfully. Let's go to the database and check the user info in the table. And as you can see, we now have the password hashed. We are not storing the password in the plain text manner. We are storing the hashed value because now we are using PasswordEncoder. So we successfully have the user info inserted in the database. The next step is the authentication step. How do we authenticate a user? How do we provide the user and password and then match it? So the part one we are already doing. We are storing the user info. Now we will focus on the authentication part. So let's go back to the application. Let me stop the application here. And the second thing is to authenticate the user. To do that, first I will add a private endpoint because this registration endpoint is a public one. We are excluding it from the authentication. Let's name it greet controller. And this is going to be a REST controller with a URL pattern of, let's say, API/greet. And then it will have a simple method like this, a get method. Okay, now what do we do in this greet method? So you remember we talked about the security context holder. Okay, so if the user is authenticated, Spring Security will add this authentication object to the security context holder, and this authentication object holds principal, which is the user, authorities, and credentials. So that means we can access the authenticated user using this authentication object from the security context holder. So that's what we are going to do in this method. Because this is a private endpoint, that means only if the user is authenticated, he or she will be able to access this endpoint. So that means if the request comes here in the greet method, the user is already authenticated. So we will access the user information from the authentication object. How do we do that? So here we will first get the user from the security context holder. Okay. So for example, this user is null for now. And then we will simply return a message. For example, something like, hi, user, you are allowed. All right. How do we get the user from the security context holder? That we will see soon. Okay. So this represents a private endpoint. The second thing is When the request comes to the Spring Security, let's go back to the architecture. When the request comes to the Spring Security, it will call the authentication provider finally, okay? And the authentication provider needs to know the user detail. It needs to read the user data. In this case, because we are storing the user information in the MySQL, we need to provide a way for the Spring Security to read the user by the username from this MySQL database. How do we do that? We talked about this. We need to use the UserDetailsService. So because we already have the user service, so what we can do, we can implement this user details service, and it has a single method which is load user by username. So whatever username we are getting in the authentication request, because now we are providing an implementation of user details service, Spring Security knows that there is this service which has the implementation of load user by username. It doesn't care about the implementation. It just needs to know that there is some implementation which is implementing this method, because Spring Security will call this method to get the user details. Otherwise, it has no way to read the data and match it against the entered username and password. Now the task is we need to provide the implementation of this method. All right. Again, what is this user details? It is another interface provided in the Spring Security that represents the user. So we will have to provide the implementation of this user details as well. All right, in a way, of course. So we are one step closer to reading the data from the database and comparing it against the username and password that the user has provided. So how do we read the user? We know we have the user repository, but now we need to read the user by the username, okay, not by the user ID. So that means we can write a new method here, something like this: user find by username, okay, and then username. So what Spring Data will do, by reading the method name find by username, it will write a select query. It will generate the select query at runtime, and it will use the username in the where clause, because we are using find by and then the property or the attribute. This is plain Spring Data that we have covered in this video as well. All right. Now coming back to the user service, what we can do, first of all, we will read the data from the database. So that means we have user u equals to user repository dot find by username, and then we will pass the username. So we have the user from the database. Once we have the data from the database, which is the user entity, which is written by us, okay, this is written by us. The second step is we actually need to return the user details, because Spring doesn't know anything about this user entity as far as Spring Security is concerned. Spring Security needs an instance of user details. So we need to convert this user to something called user details. How do we do that? Well, there are different ways to do that. What I'm going to follow is we will create a new model, and we will call it authenticated user. And this authenticated user will implement the user details interface, okay? And this user details interface has some methods which must be implemented, which is basically get username, get password, and get authorities. Okay, so right now we are not dealing with roles, permissions, and authorities. So let's keep it as it is. As for the username and password, we can get this information because we have already read the data from the database. So for example, what we can do, we can have the user entity here like this, and we can get it injected. Like this, and then we can use the same user object to get the password and get the username. Okay, let's go back to the user service. here what we will do, we will create the object of authenticated user like this, and we can pass the user that we have fetched from the database, and then we can simply return the user. Or to simplify this, let's remove this line and write it like this. That's all. So let's recap what we did. We implemented the user details service, which has a single method load user by username, which will help Spring Security to load the user by the username. Okay. Then we are reading the data from the database using plain data JPA, Spring Data JPA, nothing special about it. And the only thing else that we did, we created a new class authenticated user, which is implementing the user details, which basically represents the authenticated user as the name suggests. All right, that's it. Now what Spring Security will do, when we access the private endpoint, it will trigger the Spring Security flow. All right, it will see that it has an implementation of UserDetailsService. So this method will be called, the data will be fetched from the database, and this object has the username and password. So Spring Security will match the username with this username, okay, and the password with this password. Now the thing is, the user will provide the password in the text format, but the database has the password in the encrypted format. Spring Security will automatically use the password encoder that we have configured in the security config, which is this one, and it will use the method. There is a method matches. So it will use this method basically to compare the passwords. This is the raw password that the user will provide, and this is the encoded password which will come from the authenticated user. So that's how Spring Security is going to authenticate the user. So we have implemented the key details. Let's restart the service and test the flow. So the server is up, and one thing, if you notice, we don't see the random password generated anymore, but here we can see now the Spring Security knows that we have a user details service which is implemented by the user service. So it knows where to find the user data. You can see it here. All right. So the first thing first, let's see if we have the data available, because we have the DDL auto as create, the data is removed. So first we need to hit the register endpoint to add the user. Let's do that. We get the user created successfully. All right, let's check the database, and we have the user details in the in the encrypted format. Next we'll go to the Postman, and this time we will hit the private endpoint, which is the greet endpoint. All right, this is going to be a get call, and the endpoint is going to be /API and /greet. Okay, now before we move on, we actually missed one thing. If we check the controller, we missed to read the username from the security context holder as we intended to do. So let's do that. Otherwise, we will simply see null in the response. So we know the authenticated user, if the authentication is successful, will be stored in the security context holder. So first we will access the security context holder. From the security context holder, we get the context, and from the context, we get the authentication object. As simple as that. So from the security context holder, we get the security context, and from the security context, we get the authentication object. And once we have the authentication object, we can get the principal, the authorities, and credentials, and so on. So let's see, we get the principal, which represents the user. Now, if you notice, it is returning an object, and this object is nothing but the authenticated object, authenticated user that we created here, which is an implementation of user details. All right. So we'll have to cast it like this, and then we can use user.getUsername. As simple as that. Let's restart the API quickly. So the service is up. Let's go to the Postman. Again, we need to register first because the data has been wiped out from the database. Okay. So user is created successfully. Now we will access the private endpoint, and this must be greet. So because this is a private endpoint, so that means the user must be authenticated, which means user must provide the username and password. how do we provide the username and password using HTTP Basic using Postman? So in the authorization tab in the Postman, here we can select any authentication type which is supported, and you can see a lot of authentication types like bearer token, basic auth, OAuth, API key. And as we go on with the playlist, we will cover most of them in the hands-on videos. But for now, we will simply focus on the basic auth because we are learning basic authentication. So we will select basic auth. And as we select the basic auth, we see two fields, username and password. So let's provide the username, which is simply the user that we created. So username is demo and the password is demo123. So this is going to be demo and demo123. That's it. Let's send the request and we see, hi demo, you are allowed. So that means as we provided the correct username and password, everything that we implemented using UserDetailsService and UserDetails, it was successful. It successfully fetched the data from the database using UserDetailsService. Then it compared the passwords. That means this raw password with the encoded password from the database using PasswordEncoder. And because it was a perfect match, the user was authenticated. And so the details were stored in the security context holder. And that's why we see the username correctly here. And one more thing, if we check the headers, we see the authorization header because that's what HTTP Basic is all about. We provide the encoded value in the authorization header in the request. So we see the authorization header was set and it has an encoded value. All right. But what does it represent? So let me change it. So we see, as we discussed, the value starts with basic and then we see the encoded value. This is nothing but base 64 encoded value. So if we copy this and decode this using the same online decoder that we used, in that case, we should see the username and password which were provided. And we can see this is demo:demo123, exactly what we provided. So for the same reason, this is not secured because anyone who has the encoded value can decode it using base 64 decoder. All right. So this is what we discussed in the HTTP Basic. Well, the credentials are encoded and then passed using authorization header. And when we reach to the API, okay, the Spring Security will find or will try to find an implementation of UserDetailsService because that's how it knows how to read the user. Implementation doesn't matter. In this case, we are reading the data from the database. In other cases, well, we can make an API call basically to another API which holds the user information. Ultimately, we will provide an instance of user details because that's what Spring Security recognizes. All right. And in the greet controller, we are getting the username from the authentication object, which is stored in the security context holder. That's how we implement the username and password based authentication in a Spring Boot API. It might sound complicated first, but if you rewatch the video, there are quick things that we do, all right, like providing the implementation of UserDetailsService and user details. Then in the security config, we provide the password encoder and then we configure the security filter chain. That's it. So that's all for this video. In the next video, we will enhance the same application to use permissions and roles. That means authorities, which again will be very simple if you just follow along. So if you like the video, please make sure you like and subscribe. And if you have any suggestion, put them in the comments. That's it for now. I will see you in the next one. Thanks for watching.